Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In this video, I am going to explain about various types of addressing mode. So first, we're going to see about what is the definition of addressing modes. Also, why we are going for addressing modes. If we want to represent the operands and the operations in the assembly language, we are going for various types of addressing mode. So that can be classified as the different ways of specifying the location of that particular operand in an instruction is called as a addressing mode. So the addressing mode can be used in the everything, and also the starting address of the thing is the memory segment. It can be started from starting location of the memory segment. Here we have to calculate the two things, either effective address or offset. So effective address and offset can be determined by adding the combination of the address element, either from the displacement, base, or an index. Displacement is nothing but 8-bit or 16-bit immediate value given in an instruction. Base is nothing but it can be represented BX or BP. It is a content of base register. Similarly, index can be represented by SI or DI. It is the content of the index register. So while adding these three things, displacement plus base plus index, it will get the effective address or the offset of the particular instruction. So your addressing mode can be represented. This is nothing but the different way for specifying the location of the variable or an operand. So the first type of addressing mode is the immediate addressing mode. See here, immediate, it can be represented by hash value. Here, immediate 6 value can be moved to the register R1. So we have to write it as R1 equal to R plus R1. So that both can be added, the value will be finally stored in R1. Similarly, here I have given the second example, store R2, 100H. So it is nothing but what are the values? 100H, that particular value is immediate value can be moved to the register R2. So the value 100 is moved to the register R2. So this is a represent. This is a immediate addressing mode. The next one is a register addressing mode. So while performing the addition or a subtraction operation or multiplication operation with the help of two addressing. So that can be defined as the operation of the content of the processor register in an instruction. For example, add R4, R3 or R3, R4. So what are the elements present in this particular two registers are added and can be stored in any one of the register. This can be called it as a address register addressing. The next thing is absolute or direct addressing mode. So that is nothing but the absolute value. So the absolute value of that memory location can be added with the another register value. The both can be added and stored in the R4. For example, see here I have given the load R2, 100. So that is nothing but the memory location of 100 value can be moved to the register R2. So the 100 can be moved to the register. The value present in the 100th location that can be moved to the register R2. This can be called it as absolute addressing mode or a direct addressing mode. The next one is indirect addressing mode. Indirect addressing mode is nothing but the indirectly we are mentioning the memory location, that is address of the operand in the content of the register or a memory location whose address appears in the instruction. See here in this example, if we are mentioning inside the vector that shows the memory location. So that can be represented as R0, the R0, the content R0 plus, that is a register value plus memory of R1. So some memory location, that is one operand R1. So that particular memory location we are moving, through that we are identifying R1. See here, this address is pointed to this some pointer in the memory location. In that pointer value, you are having some address value that in that particular address only your operand can be present. This can be called it as an indirect addressing. The next one is the index addressing mode. Index can be used as an offset value. So this can be used instead of pointer. So directly we have to locate the particular memory location and all. We are going for an indexing address. This is generated by adding the constant value to the content of the register. For example, 20 of memory location R1, R2. This is nothing but the R1 can contain the 1000 means 1000 plus offset value is 20. So 1020 some value is present that to be added with R2 that can be stored in the R2. So this is can be called it as an indirect addressing mode. The next thing is base with index addressing, base with index and offset addressing. This is nothing but the base value and index value can be added in that particular memory location. Value can be added with the another register that to be stored in that particular register. So only I represented over here, add R1 plus R2 comma R4. The R1 value and R2 value is added in that particular memory location. There is one value present that to be added with R4. The final value will be stored in R4. Similarly, it will have some offset value, that is the displacement value, that is 6. This 2 memory location along with this 6 can be added, that to be added with the R4 register. The final value will be stored in R4 register. This is a base with index offsetting addressing. The next thing is the relative addressing mode. Relative addressing mode is nothing but the content of program counter plus address can be added, that will be stored in the any location or a accumulator. This can be called it as a addressing mode. See here, the address that can be added with the PC counter, that will be that particular memory location, some operand is present, that we can move to the register. This type of addressing, we can call it as a relative addressing. Second thing is auto increment and auto decrement. So while going for a looping type of instruction, definitely we need of auto increment and auto decrement. If you are representing as or auto, that is incremented by 1, or will be decremented or decrement. So my current memory location is 3300. If I want to increment the thing, it will be moved to 3302. If I want to decrement, it will be moved to 3299. So this is a process can be done in our auto increment and auto decrement mode. So these are the very quite usually used addressing mode. In this way only we can able to represent an instruction in the assembly language. So based on our situation, based on application, which one is needed for that particular situation, that particular addressing mode can be used for that applications. Thank you.